Hello everyone, my name is Reddy. I'm a Partner Solutions Architect with Amazon Web Services. We also have Eric Sakowski, Lead Automation Engineer from Datapipe, as well as Rick Blaisdell, CTO of Motus. This is a high-level agenda of what we're going to cover in the next 45 minutes. I'll start with a quick intro to AWS. After that, Eric from Datapipe will talk about how Datapipe helps customers migrate to AWS. To tie this all together, Rick from Motus will walk us through how they migrated their application to AWS with the help of Datapipe. So what I want to cover in the next 10 minutes is, why are customers choosing AWS? What are they achieving with AWS? And what are some of the challenges they are facing when it comes to migrating to AWS? So why are customers choosing AWS? Customers have selected AWS for years because we have proven ourselves committed to customer success. We believe we stand apart in the market because of a couple of factors. Let me talk about each of these a little bit. The first key differentiator is our experience. We have spent over a decade building the world's most reliable, secure, scalable, and cost-effective infrastructure. There is no substitute for the experience of time, and no cloud provider has been in operation longer than AWS. Our second key differentiator is our service breadth and depth and our pace of innovation. We have been continuously expanding our services to support virtually any cloud workload, and we now have more than 90 services. Talking about our pace of innovation, we launched more than 1,000 new features and services in 2016. Our third key differentiators are our global footprint, our pricing philosophy, and our ecosystem. To support our global customer base, we operate around 16 regions and 42 availability zones across the globe. When it comes to our pricing philosophy, our massive scale provides huge economies of scale, which lowers our costs considerably. Since 2006, we have reduced our prices more than 50 times. When it comes to the cloud ecosystem, AWS is the largest ecosystem by far, and that continues to grow at a rapid pace. It's very likely the SI and ISV partners of choice for a lot of our customers are already partners of AWS. Having this support in place is key, and it makes it much easier to adapt and shift existing workloads to the cloud. So I just talked about why are customers choosing AWS, but what are they achieving by adopting AWS? Let me share a couple of customer stories. Now everybody knows Netflix, right? Netflix runs everything out of AWS. They have around 90+ million users in more than 190 countries. Using our global infrastructure, they're able to quickly scale and service their user base without having to purchase expensive hardware or having to manage data centers. Now, Capital One of the nation's largest banks, is using AWS as a central part of its technology strategy. Capital One selected AWS for its security model, as they believe that they can be more secure on AWS than in any private data center. GE Oil and Gas is a business unit of GE. GE Oil and Gas is migrating 500 applications to the AWS as part of a major digital transformation, helping it attain a 52% reduction in TCO. These cost savings are in addition to other benefits such as greater speed to market and more agility. Another customer is Expedia. Expedia's engineering team realized that they had to run one of their key applications in locations physically close to customers in order to improve the performance. Expedia launched this application initially in Asia-Pac region and then quickly replicated the service to the US and the European Union regions. According to Expedia, latency was their biggest issue. Using AWS multi-regions, they were able to decrease average network latency from 700 milliseconds to less than 50 milliseconds. So customers adopting AWS are able to scale quickly, like Netflix, be more secure, like Capital One, save costs, like GE, and improve performance, like Expedia. A lot of enterprise customers understand the benefits of cloud. They want to be able to focus more on their business and innovate like a startup. However, they have some real questions that they want help with when it comes to migrating to cloud. Questions such as, what do we do with our existing investments, right? How do we get some of their existing skeptical stakeholders on board? Will there be downtime during migrations? How do we manage application dependencies during migration? What about the skills and expertise needed to migrate applications to AWS? For the last couple of years, we've been working really hard to help our customers overcome some of these barriers. I would like to talk about 3 specific areas where we think we helped our customers overcome some of these challenges. The first one is our partner ecosystem. We have developed a large and growing ecosystem of vetted partners, such as Datapipe, that have the experience and skills needed to execute migrations. They can help you determine your migration strategy, create a clear roadmap for migrations, bring the skills that you need to successfully complete the migration, train your resources, and do a handover to your team after the migration. They can even manage your applications on AWS if needed after the migration. The second thing we did to help our customers is to create a robust migration methodology. It starts with an evaluation process. This is where you do your TCO analysis, security and compliance analysis, identification of tools and services needed for migration. Is this application a good fit for lift and shift? Or is it a good fit for rehosting or optimization or refactoring? This is where you do the evaluation. Second step is discovery, analysis, and planning. Here you will do an inventory of your current hardware and software, identify and understand the application dependencies, and create a plan for migration. The third step is design. Here you will identify the AWS services that you want to use for your application and design the infrastructure to meet your requirements, such as security requirements, compliance requirements, cost requirements, and even high availability requirements. Next step is the actual migration. Here you will make sure you have the right people, tools, and processes in place for a successful cutover. Final step is operations and optimization. Here you will optimize the application to run efficiently on AWS. For example, you can shut down your development servers after business hours to save costs. This whole migration process should look very familiar to anyone who have migrated technology from one platform to another before. The third thing we did to help our customers overcome some of the challenges with migrations is by developing a robust set of services and tools around migrations. Some of the services are AWS Application Discovery Service, a service that can help customers plan application migration projects by automatically identifying applications running on on-premise data centers, their associated dependencies, and their performance profile. Another service is AWS Migration Service. It's an agentless service that allows our customers to automate, schedule, and track incremental replications of live server volumes, making it easier for you to coordinate large-scale server migrations. Another service, one of my favorites, is AWS Database Migration Service. Helps our customers migrate databases to AWS easily and securely. The source database remains fully operational during the migration, minimizing downtime to applications. AWS DMS service supports both homogeneous and heterogeneous migrations, such as Oracle to Oracle or Oracle to Amazon Aurora. We have also developed a set of tools to help customers transfer data to AWS. For example, Snowball is a petabyte-scale data transfer solution. Snowmobile is an exabyte-scale data transfer service. You can transfer up to 100 petabytes per Snowmobile. Just to quickly summarize, I talked about why are customers choosing AWS, what are they achieving with AWS, what are some of the challenges customers might face with AWS migrations, and how are we helping customers by overcome these challenges when it comes to building a good ecosystem, building a good methodology, migration methodology, and a robust set of services and tools to help our customers around migrations. With that said, I would like to introduce Eric from Datapipe, one of our premier consulting partners who has specific experience and competency around migrations. and AWS more broadly. Thank you for being here, Eric.
Thank you, Sai. Hello, everyone. I'm Eric Sakowski, Director of Delivery Engineering at Datapipe. I'm going to talk you through a little background on Datapipe and our competencies on AWS, and a little bit about our approach to both migrating to and running on AWS. So we are a managed services provider. We are 24/7 by 365 global organization that can take you everywhere from security and monitoring to migrating to planning new applications and architectures. We have a lot of expertise in migrating and managing and securing cloud environments. We're a leader in the Magic Quadrant for cloud-enabled managed hosting from Gartner. Some of our differentiators are a number of the competencies that Sai had mentioned earlier: the migration competency, the Exchange competency, Oracle competency, SharePoint competency. We're a premier consulting partner, and we have formed with AWS the Global Cloud Center of Excellence, which focuses on developing a framework to help enterprises simplify migrations. And in the bargain, we enable hybrid cloud architectures where you may have some things that won't transfer as well to cloud, like some legacy Oracle databases, for example. And so we have data centers all around the world to help support that type of architecture as well. One slide too far. So we integrate seamlessly with AWS. We have internal systems tied into AWS that are available for customers, as well as our own internal tooling around AWS to help us more quickly respond to customer needs. And we have developed a needs-based toolkit. And so what that means, and these are only a few of the technologies we work with, depending on the customer's business need and application architectures and database replication needs, there are so many tools in the ecosystem that, to us, we can't standardize on just one because different tools are needed for different jobs. You don't want to use a hammer if you need a screwdriver. And so the reason we've developed all of this internal tooling and all of these skills and expertises in configuration management and infrastructure as code is that AWS makes it really easy to spin up dozens or hundreds or even thousands of servers in a matter of minutes, with the caveat that now you have hundreds or thousands of servers to configure, install, secure, and manage. And so that's where automation and infrastructure as code, image factories, and automated configuration management really become important. We use the latest technologies to help customers achieve success. We use and contribute to open source projects where it makes sense. We're sometimes in the situation of really being on the cutting edge in that a tool has 99% of the features that we need for a customer, and we find ourselves developing that last 1%, which is really, really satisfying and gives us a lot of flexibility because we're now not limited by the tool set, but only by our vision. And so when we are working with a customer and we find a new need that isn't covered by our existing tooling, we try and follow the DRY principle of don't repeat yourself, DRY. And so the way we manage this is by separating customer configuration and data from infrastructure as code and configuration management code. So we protect the customer IP, and then we have a massive library of reusable modules and templates in various technologies for different operating systems and different architectures. And we can pretty quickly apply those and repurpose them by simply changing out the configuration and data. And we can also then have a unified place to keep up with emerging best practices and counter any new security threats that are emerging by updating the reusable modules as opposed to going through each customer's applications and infrastructure as a one-off. So that lets us save a lot of time and respond a lot more quickly to incidents and customer needs as they change. We have a lot of different types of managed solutions, and so some of the services Datapipe provides, such as monitoring and security, can be fairly drop-in if there's an existing AWS account. On the other end of the spectrum, we sometimes can come in at the planning stages of a new cloud-native project and provide architecture analysis and recommendations up front. But of course, this webinar is about migrations, and each migration has its own set of challenges. Some applications may migrate fairly easily. Most will have at least one or two interesting challenges that need the right solution and need some expertise to help avoid any potential pitfalls. So, for example, a common pain point is database replication strategy and how to best architect that to work in the cloud. Others is, legacy message bus layers of an application that may need some re-architecting to better work on cloud. And so we have the knowledge and expertise to recommend the best practices, all the way from making broad recommendations to actually diving down into customer code and working directly with developers, not only to pinpoint where changes need to be made, but also where a process may need to change to better support deployment to the cloud. So I guess the core message there is that the cloud is complex, and identifying the potential issues requires some experience and know-how. Datapipe has a long track record in migrations that help us pinpoint those issues quickly and before they become a blocker for the business. We have a plethora of internal tools. We use assessment tools. We use commercial off-the-shelf software where it makes sense. Where there's nothing available, we have internally developed tools that we can use to map applications and data flows and networks before a migration. And then at the start of a project, when we're assessing the applications to be migrated, we'll go through documentation, developer interviews, stakeholder interviews. I mentioned reading code and suggesting changes. We'll work with developers to identify where they need to learn a new skill and pinpoint the materials that will help them learn that so that they can prepare for the migration. Once the plan is in place, we build that solution. And here we go to the Datapipe plan, build, run model. So we've spoken about the plan. Now we build the solution. We use a loosely agile-based methodology. All the standard infrastructure we use to manage customer solutions, we already have pre-scripted using infrastructure as code with Terraform and CloudFormation. For example, every solution will need a patching relay and a monitoring collector. If we're going to be providing security services, we may need a continuous audit proxy. We may need a collector to proxy. And so all of those things are standard, and we have them scripted out. We can deploy all of that infrastructure literally in 5 minutes. It's just a matter of creating a repo and running it through our pipeline. The rest of the infrastructure is assembled using either existing modules with kind of a composable mentality in mind. So we have standard modules that we can use for auto-scale groups behind elastic load balancers for Windows IIS servers, and then we can tweak that by, again, keeping the configuration and data separate. And then we also have some standard infrastructure to support all of this automation that we run internally. So for example, we have a central image factory for standard Datapipe images of Windows and Linux servers that we can use as a start point for a customer solution. And there's facilities in there to customize that as well. So for example, we don't always use New Relic as a standard tool, but if a customer needs it, we can drop in the New Relic config flag with the customer's license key and just tack that onto the build factory and get the images shared out to the right account. And so this gives us the approach for completely custom solutions, but stands on the shoulders of all of the work and existing code that we already have. So it gives you a jump start. And then finally, looking at this diagram, we transition to the run phase. As I mentioned before, we have people around the world working around the clock to monitor and manage and respond to incidents. We, for each customer, build a server escalation action procedure, which is essentially a run book that documents how to handle every possible alert and whether that alert can be automatically corrected. You know, a 95% disk usage can be probably fixed by removing some log files pretty quickly and then notifying the customer. But we work through a custom solution to every incident ahead of time. And so we have a number of services. Some of the most common are infrastructure right-sizing, issue response and resolution. We use Datapipe 1, which is our custom ServiceNow ITIL ticket tracking portal. We have management services for custom configuring servers, taking backups, ad hoc needs such as bringing yesterday's backup online on a new temporary instance so that something can be checked. We have provisioning support. We have SLA-backed event response times, and part of that is defined in that document I mentioned earlier. And so I'm going to transition now to Rick from Motus, who's going to take you through some of the work that we did with them and how it benefited them.
Thanks, Eric. Hi, everybody. This is Rick Blaisdell, CTO of Motus. Motus is a Boston-based company. We provide solutions for mobile workers. We have a cents per mile and a graduated cents per mile solution. Most of you might be aware of, if you're getting reimbursed, you're probably under those types of plans. We also have a solution for drivers that drive over 5,000 miles a year, and we call that the favor, or fixed and variable rate solution. And on average, we save drivers $3,500 per year per driver. And these higher mileage drivers, you know, these are people that rarely get on planes or stay in hotels. Their days are spent on the road. Their cars and mobile technology actually serve as their office. And annually, Motus drivers spend about 175 days on the road. And they make more than 650 business trips and accumulate 18,000 plus business miles a year. We are the most accurate vehicle management and reimbursement platform in the market. Our configuration engine incorporates real-time data across hundreds of different variables, and this ends up saving the average company $3,500 per driver per year that I mentioned. Our solution also ensures compliance and that the employees are accurately reimbursed. The company was formed in 2004. I joined the company in 2013 along with the new management team, and we have gone from a company before doing the same kind of thing, and we converted the core business and legacy architecture into a SaaS-based platform. At that time, we created the new brand, now Motus. We process more than 2 billion miles and have a 97% customer retention rate. As all you know, that it's an extremely high and rare percent nowadays. A third of our driver population actually comes from our competitors, and we have been growing the company at 30+% year-over-year growth since we joined the company in 2013. We have a very strong native mobile strategy in our organization. Our solution captures actual mileage and also can compute optimal mileage. This all allows us to be extremely accurate on reimbursement amounts. It is fully IRS and company compliant. We have completely refactored our legacy solution into a microservices architecture. This allows us to have, tremendous scale and allows us to support tens of millions of drivers. And it has led to a 400% plus increase in development by leveraging our existing microservices when we deploy new applications or create SDKs. This architecture also allows us to package microservices into specific solutions, and we can sell that, as individual SaaS solutions. So as you can imagine, all this data we collect is very useful for predictive analytics and helps drivers and companies save additional money by making recommendations, and also helps with risk mitigation. Some of the challenges. So the challenges for us, we're moving the existing workloads from our physical, public, and private cloud environments, testing and planning for the cutover to AWS. For those of you that are not familiar with Docker, it is a technology used by companies like New Relic and Uber that develop efficiencies and scale. Basically, it allows you to wrap your software, kind of everything you need to run that application. It includes, runtime code, system tools, system libraries, and configuration. Mesos is you can access the orchestration layer and works with Docker to streamline the continuous integration and delivery of Docker containers. Motus we were an early Docker adopter. We tested and the results achieved were huge for us. It used to take us weeks to deploy new environments through the SDLC process, and we moved our workloads from dev to test to QA to staging and production. Now we are able to push through those stages in a matter of minutes and hours. And part of this efficiency is that we no longer have that man in the middle where between each stage of configuration, and starting and stopping servers used to take weeks. So to be able to bring that down to minutes ended up saving us hundreds of thousands of dollars per year and sped up the time, our development time, and to be able to deliver new features. So this led us to where we are today with AWS and Datapipe. Our initial workload tests at AWS were very promising and met our expectations with the regional failover capabilities and coastal disaster recovery and failover options. But we still needed to find a managed service provider that was well known and experienced in migrating and managing complicated environments. We were hoping to find a managed service provider with deep Docker experience. We were a little too optimistic there, I think. Although after talking with Eric and the team at Datapipe, we felt comfortable that they would invest the time in learning Docker and all the automation requirements we were looking for. It was a good size, as Eric will mention more probably during this presentation. It was a good size migration. Datapipe worked closely with us to ramp their team and learned our technologies, and also helped us automate the environment. As I mentioned previously, Motus's use of Docker containers, has brought a myriad of benefits to the company, from the ability to roll out these new products into new markets in a matter of minutes and hours, not days and weeks. I cannot remember this quote. I don't know if this was from Scott Rankin, Motus VP of Technology, that was instrumental in this, also working with Datapipe, as well as Matt Richter from Motus. But Datapipe did get us to a good place with a minimal amount of effort, and their migration and automation experience was very helpful. I'm going to hand it back to Eric here because talk through this slide. He was really instrumental in managing the initial project and helping us re-architect the public code base, and also leverage the AWS and Datapipe services and tools. So Eric, if you don't mind jumping in, that would be great.
Sure. So when we came in on the Motus project, as Rick mentioned, we did not have a whole lot of Mesa's experience on public cloud. That was something new to us because Motus was really ahead of the curve on that one. So we did invest the time to learn it and suss it out. It helped that Motus already had a good deal of automation in their solution using Puppet and Ansible to manage deployments. Some of the Puppet code was from an earlier period and needed some work both to re-architect it to work on public cloud. So certain things like instance names and service discovery had to be retooled and sort of reimagined to work. And we made heavy use of AWS's Route 53 DNS as a service there. And then we also wanted to leverage the AWS self-healing infrastructure with autoscale groups. And so we created a fair bit of tooling to add on to the existing Puppet code and also worked directly with Motus's code repository to make these changes so that we could have an autoscaling event, bring up a new instance. The instance automatically checks into Puppet with its new host name, automatically checks in with Route 53 to put itself into DNS so that it can be discovered, and is also automatically assigned the necessary classes and packages to install and the necessary configuration for the workload that it's going to be taking on. So this allows, rather than having to manually create a new instance, get on there, name it, put it into DNS, install a bunch of packages, make sure it's checked into the cluster, you just go into your console and say, I don't need 3 now, I need 5 now. Or you can tell autoscaling with AWS that when this server reaches this amount of load for this amount of time, scale up by 10% of the autoscale group. So if you have 10 there, it's going to bring it up by 1. So you can make a lot of interesting settings like that. But it's necessary to prepare the field first and make sure you have the right automation tools. Otherwise, you're going to autoscale an instance that doesn't have any of the software that it needs to be productive. The other thing that we did to really take the human effort and possibility of human error out of the solution was to put all of their build into Terraform for infrastructure as code. And so Terraform allows us to really control how the autoscale group is set up, how the launch configurations are set up, what Route 53 is going to look like as far as the overall domain, route tables, customer CIDR blocks that need to come in to input their data into the solution. And we tooled that using Jenkins, which automatically sees any merges to the infrastructure as code in the source code management system and triggers a Terraform plan. What the Terraform plan does is it tells you, okay, I have some changes to infrastructure as code. I'm planning it against the existing environment, and here are the changes that are going to happen. And it might be something like add 1 security group rule or add 1 instance. And so then a Datapipe engineer comes in and reviews the plan, makes sure that it meets the business need and the technical needs. So not only is it doing what the business needs, but technically it also makes sense and it's not going to delete anything that it shouldn't or modify a resource that shouldn't be touched. Once it checks out, he can click promote. Terraform connects to AWS API and makes the changes. So there's no more manual intervention to spin up, for example, a new development sandbox, or to spin up in Oregon if there's something going on in the east, or if you want to expand to Europe, you can make a few changes and rerun that code in the different regions. And so we worked very closely together, and we versioned our Terraform code. Motus picked up a little Terraform, I think, and at the end of the engagement, once the Puppet code was up to speed with some technologies like Hira and that allow us to separate configuration from program code, we actually handed back control of Puppet to Motus, and that was pretty awesome. Also throughout this process, we had a lot of changing requirements because it is Docker and microservices, and there is very fast iteration in that development process. And so also having access to the Datapipe support engineers like King Cruz in the Unix department to come aboard and help out with things like clusterfs and managing all of the complex DNS entries was awesome. I think that's all I have to say. If you want to take it back, Rick.
You got it. Thanks, Eric. I really appreciate that. So let's see here. Go next slide. There we go. So hey, this is a high-level diagram of our environment. You know, it probably looks pretty basic. You know, you've got your databases, Postgres databases. You can see, you know, the cluster shared file system that we back up to and sync to S3 and Dropbox. There's a few takeaways though here that worth mentioning. You can see where those meso slaves are in the diagram, and that's kind of where, you know, Motus' all the magic happens and orchestrates the entire workflow of the business. And that's all our tiers, such as the app layer, the UI layer, and the business layer, are all executed as Docker containers on those meso slaves. And the other thing to point out too as well is the HJ, or the proxy behind the ELBs. That's kind of like Motus's, you know, that was part of the Motus's existing environment and specially configured. And Datapipe worked, you know, really well with us on that to make sure that, you know, we kept that integrity and the configuration as we work together on this plan here and rolling out and migrating. So we really appreciate that. So at this point, you know, we're 100% of the company's production workloads are running in AWS. We are leveraging availability zones in 2 West Coast regions and 1 East Coast region. And Motus has drastically reduced the time it takes to roll out these new services, as we talked about. Motus is ready for growth, is able to quickly spin up and scale new environments through auto-scaling to handle our peak loads that we're experiencing, that we usually experience just, you know, 2 days a month is extremely high loads for us when we're running MRRs. And we save a lot of costs during the non-peak periods and reducing resources when not needed. That, you know, it's not the saving is only saving, it's not only saving 20% from AWS services automation, but it, you know, it's given Motus a huge, you know, I would say in some way, and even the salespeople here tell us, you know, it's almost like, seems like an unfair competitive advantage, you know, how fast we can build software and then deploy it to the market. We are, you know, and we're also today, we're working with our global partners, and we're planning on rolling out our infrastructure worldwide in 2017. And we expect our growth and scalability in AWS to continue and grow at the same rate year over year. So at this point, that's it from my end. I did get a question that came across, and it mentioned there was a few things. How long did it take for Motus to complete the project? It took us about 3 months, and that was a month of planning and 2 months of execution and also testing in the environment. I'm going to hand it back to Zaya.
Yeah, thanks, Rick. I have another question for you. Could you talk? You mentioned you know, saving 20% in operational IT costs. Could you talk more about that? How were you able to achieve that?
Oh, absolutely. So, you know, Datapipe has helped us with this too. You know, so this is an ongoing thing, but you know, it's really kind of you know, right sizing and running analysis on the reserved instances. And you know, that we'd come back and come up with a plan and make the changes of what things we should be, you know, pre-buying, what other things that we can, you know, save, how we can save and make things more efficient. So it was over, a period of time that, that we were, and we continue to increase that. But it's basically was in collaboration with Datapipe. I'm just looking at those resources and watching over them carefully.
Okay, thanks, Rick. Another question for Eric. Eric, what are some of the tools used for this migration?
Sure. So we used Terraform. We used CloudFormation. At the time Motus came into Datapipe, we had a pre-existing CloudFormation template for all of our base VPC architecture. We have since transitioned that to Terraform. Terraform is a DSL, a domain-specific language from HashiCorp that lets you write pretty human-readable code that describes your AWS resources and that allows you to version that through the use of a state file. And so we use an automated pipeline that we've developed using GitHub Enterprise, Jenkins, and AWS encrypted and versioned S3 buckets to store that state file. And the way Terraform works is when you start a Terraform run, it compiles your code that describes the resources and what the state of your infrastructure should be, and then compares that to the existing resources stored in the state file, and then determines where the differences are and how to make the changes necessary to bring the environment and then the state file into line with what the code says things should look like. And then we also use Puppet to configure and manage software on the actual instances. And I believe that Motus continues to use their Ansible deployment code, which we did not affect because Mesos, once you get it all up and running on AWS, it is an API endpoint. So I hope that answers the question. Thank you.
Okay, thanks, Eric. I think the next question could be, please feel Eric or Rick, both of you can chime in. How did you discover application interdependencies for this migration?
So a lot of that was, well, fairly simple, but there were some outliers and edge cases that we discovered as we went. We used an iterative process. So the nice thing about Terraform, especially when you're using an operating system like a Linux, such as CentOS or Red Hat or Debian, is that once you have your Terraform code in place, you can run it and allow that machine that you've built to execute all of its code and then look at it, because it takes about 4 to 5 minutes to spin up the entire solution. And so Motus has their own internal tests, and we developed some user acceptance tests, automated tests that we run against the solution. And so we kind of used an iterative approach there. We would build it and see what didn't work, and then see which tests failed, go back and make changes to our infrastructure as code and Puppet code to make that problem go away, tear down the whole build, and run it again. It makes for a really awesome, repeatable process. You don't have to spend days and days tinkering with this instance or that database. You can just tear it down and rebuild it and make sure that you have it all right and that it's all in the code.
Okay, thanks, Eric. Another question, how did Motus migrate their data to AWS?
You want to take that, Eric? I think it was mostly we used the manual. It was mostly manual migration.
Yep, it was mostly manual migration. So because of the data retention and data loss acceptable policy from Motus, they had some unique requirements around that. We worked closely with the Datapipe Managed Services database administration team, and we brought in some subject matter experts for MySQL and Postgres. And so we wound up migrating things fairly manually, but setting them up in a way that allowed for very fast turnaround and minimal data loss with multi-region disaster recovery.
Okay, great. Another good question. I do not use Docker. Is that a requirement? Eric, do you want to take that?
Oh, absolutely not. It's not a requirement at all. It's one of the things that made this migration stand out. But we've migrated everything from legacy C applications to older Java applications to Docker microservices. So we span the full range of technology deployments. We use Puppet, Chef, Ansible, Capistrano. We have used Ant and Gradle to deploy applications. We have some solutions where there are WAR files being uploaded to watch S3 buckets, and as soon as they're uploaded, they're deployed. But yeah, we work with the customer to come up with the right solution for them that allows them to get the application into the cloud in a way that makes sense for cloud. And there are a variety of requirements. The only thing we really can't do is run a really old end-of-life operating system that just will not run on modern hypervisors. That would be the only restriction. But Docker is definitely not a requirement.
Okay, thanks, Eric. There was a question about the operations part of this after the migration. Can you talk a little bit more about that? What about the integration process, like ticketing systems and things like that between the customer and Datapipe?
Sure. So depending on the project needs, it varies where the operations team comes into play. We like to get them in right up front, at least so they get a little familiarity with the client and the needs. And once that, so they sit in on things, and we document everything very, very well. We diagram everything. Once the build is done and transitions into operations and support for the day-to-day, we have that documented server escalation action protocol. We have a service delivery manager who is familiar with the solution and with all of the stakeholders on the account. The customer has been trained on our ticket portal and our process, and there's a whole step-by-step process to both introduce the support team to the solution and have them review all the documentation. There's customer sign-off on that documentation, and there's training for the customer on how to quickly get the most out of Datapipe. And for any questions, there's the service delivery manager and the global support team to answer questions.
Okay, thanks, Eric. There was another question about data replication. It was stated that data replication is always tricky. Did you see that in your migration with Motus? Any issues with data replication or any lessons learned there?
There were no specific issues or lessons learned on this, but that is probably because we have some really great database administrators, and we brought them in very, very early on this process to manage the data replication, and so they made all the right decisions, and there wasn't a real problem with it. It was just the time it took to get the data moved into the cloud. So it took a couple of days, but no, nothing really stood out about the replication for this one. Where we see some challenges that have to be overcome and have to be well thought out and architected is for things like transactional replication in Microsoft SQL Server. So that may or may not work in a multi-region disaster recovery scenario, whereas in a typical data center, it might make a lot of sense. That sometimes has to be rethought and re-architected for the cloud, because there are different requirements and different strategies for achieving your durability and your availability in cloud than there is in the traditional data center.
Yeah, and it's Rick here. Just wanted to add too that we had our own, Motus had our own series of scripts for this that we use for testing the replication, not only on the database level but at the data level itself.
Okay, thanks, Rick. There was another question about as Datapipe with experience doing these migrations, do you have any reference architecture or a methodology that you developed to help other customers with similar migrations?
No, as I think I mentioned before, we do have a kind of tool agnostic approach. We definitely have some core really deep expertise in both Puppet and Chef. So those would be kind of our go-to. But if a situation calls for Salt or Ansible, we have no problem using those either. I suppose the reference architecture or model would really be encapsulated more so by the white papers on AWS best practices in security and architecture, so separation of duties, least privilege, using microsegmentation to secure every layer of a solution. And we follow that as best we can in a way that makes sense for the solution at hand. But we don't really have a one-size-fits-all reference architecture because every customer's needs are different.
Well, thanks, Eric. There's another interesting question about how did Datapipe bridge the skills gap in deployment of this Docker solution on AWS?
Right, that's a great question, actually. And that's why I really love this engagement with Motus, because we work very closely with Rick's team to the point of having an open, internet chat channel with the team and regular calls. So Mesos, not so much Docker, but Mesos can be very tricky at times, and Mesos is kind of the compute manager that allows Docker jobs to scale and to make the best use of available compute resources so that you're not wasting 8 gigabytes of RAM on a Docker server that's a standalone Docker. You put that into a Mesos cluster, and Mesos manages that, so when a job comes up that needs 8 gigs of RAM, you push that container over to that Docker Mesos worker. So we read a little about it. We already had some familiarity with Docker itself. By going through the exercise of helping re-architect Motus's Puppet code that already configured Mesos, and by working with Rick's team as Mesos subject matter experts, we were able to get what we needed from them in order to use our expertise in AWS and Puppet and automation to deploy Mesos in a repeatable manner. So it was a bit of give and take with both Datapipe and Motus working together and learning some new technologies so that we could achieve the business goal of getting this repeatable build on AWS for Motus.
Thanks, Eric. Another question, if you're running your own proxies, will those proxy services and collectors remain after the migration is completed?
So those are proxies that are put in place to supply services under the Datapipe Managed Services Agreement. So if you transition away from Datapipe Managed Services, Datapipe will no longer be managing the services, in which case, it's just an instance. You can shut it down if you have made the decision to go out from Datapipe and choose a different vendor. But yeah, you wouldn't want to maintain a patching relay into Datapipe's central DB if you were no longer using Datapipe. But the licenses are under the Managed Services Agreement and under the Managed Security Services Agreements if a customer opts for security service.
Okay, thanks, Eric. Another question, again, about data migration. Have you used database migration service? If not, when would you think about using DMS?
I personally have not. I know that some of our database administrators have used it and actually helped alpha test that in the very early stages. So that is a question I would leave up to the subject matter experts because databases can be tricky. I know that we do use it when it makes sense, but I haven't used it myself.
Yeah, I can add a little bit to this question, Eric. I think you could use DMS when you're thinking about if you have a system that cannot take any downtime, you can use DMS to minimize downtime, almost near zero downtime type migrations. Also, if you're thinking about modernizing your applications, maybe migrating from maybe a proprietary database system to more like an open database system, you can use a database migration service for that kind of modernization, both homogeneous migrations as well as heterogeneous migrations. Sometimes you don't even have to make any modernization. You're just thinking about lift and shift. You can still use DMS just to minimize downtime and for a continuous replication basis. Let me see if we got any more questions here. So question to Rick, you mentioned cost savings, you mentioned using AWS and with this migration almost a competitive advantage to Motus. Can you elaborate on that? Can you, what are some of the benefits after migrating to AWS? Like something about agility you mentioned.
Yeah, absolutely. I mean, there's a lot of benefits on the AWS side. Disaster recovery was a big one, right? And how we can, replicate and have, hot failovers from the East Coast and West Coast and regional failovers. That was huge. Also, I mentioned that we were going to go international, and we're planning on, we got our containers, we're going to be, bringing them over to international data centers as well. The other thing is, like the CloudFront, that technology, where, it's probably the same thing I think Netflix is using, right? So if you're, that edge network, some of that content is delivered to those devices at the edge of the network, and the same thing is true with us. So there's just, the wealth of services that AWS has, and, we utilize a lot of those services. We've learned a lot about how AWS has, microservices and how, that's kind of how we're starting to build our platform as well, as a technology company.
Thanks, Rick. I think we're almost at the top of the hour here. Thanks again, Eric and Rick, for sharing this wonderful migration story, some of the lessons learned, and tips to our attendees. Thanks to all the attendees for taking time to attend this webinar today. This concludes our webinar. Have a great rest of the day. Thank you.